8.3, Describing and Analyzing Data. We are going to move from portraying data graphically to how we can analyze it with the numbers or the actual data. And the first thing that we want to look at is, for all of the information that you collect from a sample, how can we find the average number or the usual reading for, say we're looking at the height, we'd like to say the average height of all the people is 5'7", and have some sort of number there so that we can sort of describe the data without having to talk about every single person's data points. Well, we had one person who was 3'10", we had one person who was 4'5", we had one person who was 5 foot, and going on through every person, or even just giving a graphical description of the data, we'd like to be able to come up with the average of all those people. The average height was blah, and we're very used to using that, what the average temperature is in a city, or the average amount of snowfall, or the average height, or the average weight, or the average salary. We're very used to looking at averages in the world, and we have three ways of looking at the average, which is the middle of the data. We can use the mean, the median, or the mode. So there's three measures of central tendency. We call it central tendency because it's telling you where the middle of your data is, so the center or the middle of your data. And so the three measures that we have, again, are mean, median, mode. And let's start with talking about the mean. That is the arithmetic average of your data. And a formula, we have two formulas. One is for the population mean, and that's right here, and one is for the sample mean, and that's right here. And you can see they look the same. We have a little bit of statistical notation here, so let's talk about it. This on the numerator is telling us this is a Greek letter sigma, capital sigma, and it just is used to represent the sum. So if we're talking about the sum of x's are our data points, and this sub I is just talking about each one of the data points that we want to add up. So the sum here would be for all of the data in your data set. So we can write that down. And we don't really care when we're finding an average if it's for all of the people in your population or all of the people in your sample. We actually find it the same way. The capital N is the population size, and the lowercase n is the sample size. And then we have this symbol, which is said mu. It's called mu, and you pronounce it like the kitties meow. So we pronounce it mu. And it is a Greek letter, and we use it all the time to represent the population mean. And then we have this symbol, which is called X bar because it has a bar across the top. So this one is called X bar. And we use that all the time to talk about our sample mean. And now if we take just a step back from all of this confusing notation and think about what it's talking about, we'll see that the mean is something that we know already. And up on the numerator, it's showing us add up all your data points and then divide by how many data points you have. For this sample, the same thing, add up all your data points, divide by how many data points you have. That is an average. That is the mean that we've been calculating as an average, like our average bowling score or our average for a baseball statistic, anything like that. It's the same average. Average for your grades. If you're doing the average exam score for your class, same thing. Add them all up, divide by how many you have. And this is formal notation to show us that we just want to take the average, add them all up. That's what that numerator is saying. Divide by how many you have. And so we're doing a regular old average, just like you've been doing up until this point, without knowing that we had a fancy statistics formula that tells you to do the same thing. So that's our formula. And a little more depth is to show this is very formal right here. It means the exact same thing as the numerator. It says start I at 1 and go all the way up to your sample size, and then put in each x with that subscript that comes from the I. So you're going to start with 1, so you would have, down here you would have x sub 1 plus x sub 2 plus x sub 3 plus on and on until you get to the very last data point in your sample set. This is what this formal notation is telling you. It subs in with those x's that you're adding up, and that just means each data point. And so here it is again, add or sum all the values in the data set, add them all up. And n is how many values you have. So once you add them all up, you'll divide by the n. So this is another way of looking at that same formula. I don't want you to be scared if you see it. It just means add everything up and divide by how many you have. So we see it up here in one form and down here in a slightly different form, but it means the exact same thing. So if we're finding the mean for a given data set and we want to round to the nearest tenth, I see 3 numbers here that I want to add up, and I can do this one by hand partially, I think, because this comes to, if I add these two, I get 11, and then add in that 13, so that'll be 24. So I have 24, and then that's the sum of all my data points, and then I have to divide by 1, 2, 3 because there are 3 data points. My n is 3, so I'll divide by 3, and I will get 24 divided by 3 is 8. And so that is, I don't know if it's a sample or a population because I'm not told, so I can just guess. Since there's only 3, it might be a sample mean that I just found, and so I can put x bar on it. And it said round to the nearest tenth, but I didn't even need to round because it came out to a whole number. So that's my first mean. I could do it on the calculator, 8 plus 3 plus 13, and I get 24, and then divide by 3, and I get 8. So I've double checked myself there. Here's some for you to try. Go ahead and pause the video, give these a try, and then you can check what I got and see if you're on the right track.